Hello everybody. It's been a while since I posted any videos at all, but I'm going to try to get back to it now. I'm like an electronic hobbyist enthusiast, and I build a lot of little projects. Today I built a little amplifier for it can be used with an iPad or your PC or your cell phone. It takes a small audio signal and amplifies it, probably around 35 watts. There's a couple ideas. I could have used the MOSFET or op amps, but I found this one chip called a TDA 2030A, and here it is right here. Let's see if it'll focus in on that. Boy, can you read that? No, this is a 7905 regulator. Hold on. Oh, here it is. I've already got it placed on a board. It's right here. Let's see if it'll focus in. Anyway, so here's the circuit. I'll show you the chip on my breadboard. I found this online. I made just one or two changes to it. The one that was online didn't have a potentiometer built in for volume control, which I put right here. I put a 10K pot in there. What else? I think I added a filter cap. I'll show you on the breadboard. So that's what the circuit looks like on paper. Here it is on the breadboard. So your audio signal comes in from the PC right here. Right here. Here is a 3.5 millimeter jack that I cut off, and it's 2 channels, and I'm only amplifying 1 channel, the white wire right there. I'll have to build another amp for the other channel. It's fed into the center pole of a 10K pot, and then it goes to the pin 1 of the chip, which is right there. It's coupled through a cap. Couple things that I noticed when I built it. It was pretty noisy, and 1 millivolt of ripple at the input is gonna times 30 that on the output, and you hear it. So adding a couple filter caps helped out. There's one, and here's a real important one. This is just right across the supply, and it works pretty good. So let me play something here on the PC. Well, I have an anime on there right now. Let's see. So there's my test speaker right there. So if I pull this cap off across the supply, you'll hear a high-pitched whining come in. So that's like a high-pass filter or a low-pass filter. High-pass filter. No. It basically sends high frequency to ground. So what would that be? A band pass? Anyway, volume is right here, and this chip is currently running off a 12-volt supply. Let's stop that. It's currently running off a 12-volt bench supply right here, and ground. However, it is capable of plus and minus 20 volts. So I built a little power supply that I'm going to use as my power supply for my actual device, and I'm going to put it in an enclosure or mount it and use it. So I've already started building it. The power supply itself is built. Basically, it's just a step-down transformer. It takes 110 and steps it down to about 44 volts peak to peak, and then that I put through the rectifier right here, filter the positive wave and the negative half of the cycle or wave, and then I end up with ground, minus 20 and plus 20. These little amplifier chips do get hot, so a heatsink is recommended. I might just use a little cooling fan and run it off of a 5-volt regulator, which I have right here, 7805, and then I'll mount that fan somewhere near the chip, the IC. So the only parts that are needed for this simple project are 7 resistors, 6 capacitors, 1 diode, 1 LED for power on, a potentiometer, a speaker, which I'm using a test speaker right now, and the 1 transistor or amplifier chip, which is the TDA 2030, which is right there. Okay, so the values I wrote in pencil there, so that you need 4 100K ohm resistors, 1 4.7K, 1 1K, and 1 1 ohm. Capacitors, you need, oh boy, what does that say? 1 2200 microfarad, 1 47 microfarad, 1 microfarad, 1 10 microfarad, 1 1000 microfarad, and 1 104, which is 100,000 picofarad. 100,000 picofarad, yeah, that's correct. 100,000 picofarad, which would be, I don't know, 10 to the minus 6 is micro, so I don't know, I have to figure that out, how many microfarad that would be. So it works pretty good. I'm just gonna transplant new parts onto this little circuit board right there, and using this power supply, which I put a little switch in and a fuse, and put it on these little perforated boards, which I got from Amazon. It was only like $5 for all these boards, these little mini boards. But that's it. I'll give you another screenshot of this. Oh, that just turned everything sideways, but that's the circuit diagram. So the next thing I'm gonna build is an oxygen or air quality sensor project. That's just gonna check to see how clean the air I breathe in is. With that, it'll be an Arduino project, and I'll be using one of the many different gas sensors that they have. I don't know the name of it right now, but that's going to be my next project. Stay tuned. If you have any questions or comments, please leave them. I apologize for my poor quality video. I promise, as I keep building circuits and explaining them, I will get better at this. So I'm pretty new at it. I also post piano practicing, like me playing the piano, little intros, and I'd like to get a group together there of people who are like me, amateur pianists trying to learn. But yeah, that's about it. Thank you.